Hello, everyone. It's Mr. Kissinger at the Citizenship Academy in Syracuse, New York, and this is 5th grade math, module 5, lesson 17. We're going to draw parallelograms to clarify their attributes and define parallelograms based on those attributes. So kind of like what we were doing last time with trapezoids, but now we're going to be using parallelograms. And the difference between a trapezoid and a parallelogram, well, a trapezoid has one pair of parallel sides. A parallelogram has two pairs of parallel sides. So they're both going to be quadrilaterals, but they both are going to have four sides. But with a parallelogram, all four sides will have, each one of them will have a match with another that will be parallel with it. So let's get started. We'll start drawing some so we can kind of take a look at these. And it says for number 1 here, angle A measures 60 degrees. And it says extend the rays of angle A, and draw parallelogram ABCD on grid paper. So parallelograms, because they're a quadrilateral, they'll have 360 degrees if you add all the angles up. Because it has two sets of parallel sides, there's going to be two sets of matching angles as well. So if I have one angle that's 60 degrees, the opposite angle will also be 60 degrees. And then the two adjacent angles, the two angles that are next to each other, those angles are going to add to 180. It'll be 180 and 180 to make 360 altogether. So this will be a little easier to explain once we draw it. So let's complete this parallelogram. I have A, B, we'll call this C down here. Then we'll go here to point D. Back to A and D. And so make this point B. This is going to be point C. This is D. So now we have parallelogram ABCD. This angle right here, it tells us that this angle A is 60 degrees. So we have 60 degrees there in that angle. The opposite angle, angle C, because it's opposite in a parallelogram, will also be 60 degrees. We have this side and this side are parallel. We have this side are parallel. So if we go from this angle to the adjacent angle, to the one that's right next to it here, angle A plus angle B has to equal 180 degrees, because we'll have 180 here and we'll have 180 down here between these two angles. So what plus 60 will give us 180? That'll be 120 degrees. And then D is opposite B. That'll also be 120 degrees. So angle B, let's do it the way they did it here. Angle B is 120 degrees. Angle C is 60 degrees. And then angle D is 120 degrees. So number 2 says WXYZ is a parallelogram not drawn to scale. So this parallelogram right here. Using what you know about parallelograms, give the measure of sides XY and YZ. So we're looking for this side here, XY, and then this side over here, YZ. Now, parallelogram, your opposite sides will be the same length. That's the only way that you're going to have two pairs of parallel sides, is if we have side lengths that are the same opposite each other. So when I have 6 centimeters here, if I look at my line, my other parallel line, well, that's also going to be 6 centimeters. And when I take my 3 centimeters here, I look across the parallelogram to the other side. I know this side also needs to be 3 centimeters. So XY, let's call it line segment XY here. That's 6 centimeters. And YZ is 3 centimeters. Angle WXY equals 113 degrees. Let's write that in here. WXY right here. We have an obtuse angle. It has a measurement of greater than 90 degrees. It's going to be 113 degrees. It says, use what you know about angles in a parallelogram to find the measure of the other angles. Well, we're going to do the same thing that we did up here with these angles. We know that if this angle is 113 degrees, well, then angle WZY or YZW is also going to be 113 degrees. Well, now we have YZW right here, so we're at 113. We know that this angle and angle XWZ or ZWX, these are going to add to 180 degrees. So we have 113 plus something equals 180. Well, the way we can find that is we can do 180 minus 113. And we're going to have 67 left over. So this angle will be 67 degrees, which means the opposite angle also needs to be 67 degrees. So XYZ is 67 degrees, and ZWX is also 67 degrees. Now, number 3 is going to use the same parallelogram that we used in number 2. It says, Jack measured some segments in problem 2, and he found that WY equals 8 centimeters. So that's this whole line right here. I'm going to draw an arrow out here. This is 8 centimeters. That's the entire line. And he said MZ, which is just this little line right here, and MZ is 3 centimeters. So that's just this little segment here. We want to find the lengths of the following segments. WM is the first one, so we have WM. Well, if this whole line here is 8, and these two lines bisect the parallelogram, we know they're going to meet right in the middle of each other. So it's going to split that line right in half. And when we split that in half, and we have 8 altogether, each side, this part and this part, WM and MY, are each going to be 4 centimeters. Because 8 divided by 2 is 4. Now it wants us to look for XM and XZ. So we have XM and then XZ. Well, if MZ is 3 centimeters, well, the other half also needs to be 3 centimeters. So that XM is 3 centimeters. And then the whole line altogether from X to Z is 3 plus 3, which will give us 6 centimeters. So we're able to fill in all of our measurements and angles just by knowing a couple of our dimensions there. All right, and let's look at this number 4 here. It says, using the properties of shapes, explain why all parallelograms are trapezoids. Well, a parallelogram has 2 sets of parallel sides. So we have like 1 pair, 2 pairs. Now, these 2 sides are parallel, and these 2 sides are parallel, and that's a parallelogram. But it's also a trapezoid, because trapezoids have at least 1 pair of parallel sides. Parallelograms have at least 2 pairs of parallel sides. So if something has 2 pairs of parallel sides, it also has to have at least 1 pair of parallel sides. So this is a parallelogram. But it's also a trapezoid. Because it has 1 pair of parallel sides to make it a trapezoid, but it also has a second pair of parallel sides that makes it a parallelogram. So because it has both, it can be both a trapezoid and a parallelogram simultaneously. All right, so that's where we're going to end for today. Thank you guys so much for tuning in, and I look forward to seeing you next time.